Hello, welcome to second video, and this time we will see the matrices, and the matrices is the plural of matrix. The matrices are the most important data structures of Matlab because the Matlab is made for the matrices. And what is matrix? A matrix is a two-dimensional array, and actually a matrix can have multiple vectors. What is vector? A vector is an array, but let's say a vector is an two-dimensional array, but one of its size should be 1. For example, 1 by 11 or 11 by 1, 1 by 3, 3 by 1, for example. And a matrix can have multiple vectors, and a vector can have multiple scalars. And what is scalar? Well, a scalar is a number, for example. A scalar could be a number, could be a char, could be a string, could be everything. And in here we will mostly use we will work mostly in numbers, not chars or strings. And here, as you can see, a scalar is in Matlab, a scalar is 1 by 1 array, and a vector is an array with two-dimensional array, but one of its size should be 1. For example, 1 by 3 or 3 by 1. And matrices are two-dimensional arrays, but there is no limitation of its sizes. It could be 3 by 9, for example 8 by 5. There is no limitation in the size. And we have arrays, and arrays can have multiple matrices. How is that possible? For example, an array of matrices can have multiple arrays. For example, we can create 5 matrices and we can combine that 5 matrices into an array. Let's see in the Matlab. Let's start with a scalar. A scalar is a number. As you can see, it's a double, and its size in the workspace is 1 by 1. And if you want to define a vector, you need to define an array, and one of the size of that array should be 1. For example, let's say S equal, we need to use brackets to define array, 5, 4, 3. Right now, sorry, let me clear it. S equal 5 and V equals, I need to change the variable name. V equal 5, 4 and 3. As you can see here, the V has 1 by 3. Right now, one of the size is 1, and we can say that V is a vector. And V is a row vector. Why? Because V has 1 row and 3 columns. This is why we say V is a row vector. And there is a column vector too. How to define a column vector? Let's try. Let's say CV column vector equals, this time we can use 1, 2, 3, but this time we need to use semicolons. And 1, 2 and 3. As you can see, right now we have a column vectors. And if you want to change a column, you need to use semicolons in the matrices or in the vectors. Doesn't matter. And if you want to define a row vector, you can use 1, 2, 3. You can use spaces to separate the elements, and also you can use a comma to separate the elements. These are similar and these are same things. It doesn't matter. You can use any of them you want. And if you want to see the length of any vector, you can use length function. Let's see length v. The length v is 3. Let's extend the vector v4 equals 99, and right now we can use length function again, but the answer is 4 this time. Why? Because we extend the vector. And v was the row vector. And how about we use a column vector in the length function, cv? The result will not change. Why? Because they are vectors and they have one size, and their length, the cv, let me echo it. Yes, the cv is a column vector and its length is 3, and when I use length function for cv, it will return 3. But if I use a size function for cv, it will return 2 numbers for me. These are the sizes of my variable. And if you remember, s is a scalar, and if I use size for s, now it will return 1 and 1. Why? Because the size of s is 1 by 1. What did I say at the PowerPoint? Each scalar is a vector and each vector is a matrix. And let's define a matrix. And M equals, let's define 2 by 2 matrix, and 1, 2 is the first row, and let's change the row with semicolon, and 2 and 4. Now it will create a matrix. In here you can see its values 1, 2, 3, 4, and its size, as you can see, 2 by 2. And right now, if you use length function for this matrix, you will get 2. Why? Because Matlab gets M in here as a vector, as a row vector. For example, let's create an M equals, this time 1, 2, 3, semicolon, 4, 5, 6. And if you use a length M, it will return 3, because Matlab sees M as a row vector in the length function, and it will return the length of that row vector, which is 3. And let's write M1. As you can see, Matlab sees M again a row vector, And when you write an M1 as an index, it will return the first value of the row vector, of the first row vector. But M has two row vectors, which are one of them is 1, 2, 3 vector, and the other is 4, 5, 6 vector. And M has 3 column vector. One of them is 1, 4, one of them is 2, 5, and another of them is 3, 6. And when I write the size function for M, right now it will return the size of that matrix, which are 2 by 3. It has 2 rows and 3 columns. And let's clear the command window, and we can combine matrices and vectors into a matrix. For example, let's define a column vector CV equals 1, 1, not colon, it should be semicolon, yes, 1, 1, and 1. Size of CV is 3 by 1. It has 3 rows and 1 column. Let's create another matrix, which is let's say M1 is equals let's create a 3 by 2 matrix. 2, 2, 2, 2, 2, 2, 2, and 2, 2. Now I have 3 by 2 matrix, which all 2's. And right now I can combine this matrix and CV. How? For example, let's combine CV, just CV and another CV. For example, CV and another CV. When I write this, 2 column vector are combined into a matrix. For example, M2 is equal to CV and CV. As you can see, 2 column vector combined into a matrix. And I can also use M2 and M1 to create a new matrix. As you can see, right now my M2 is 1, 1, 2, 2, 1, 1, 2, 2, and 1, 1, 2, 2. You can combine any matrices into a matrix, but you need to care their sizes should be compatible. But how? If you combine any matrix in a row, their column counts should be same. If you combine 2 matrices in a column, their row sorry. If you define 2 matrices in a row, their row counts should be same. And if you want to combine 2 matrices in a column, their column counts should be same. For example, right now in here, let's define M3 is 3, 3, and 3, 3. The size of M3 is 2 by 2. And if you want to combine M3 and M2, it will throw an error. Why? Because the dimensions of arrays are not same. And why the size of M2 is 3 by 4, the size of M3 is 2 by 2. You cannot combine them in a row. To combine them in a row, their row counts should be same. For example, let's change M3 is 3 3 and 3 3 and 3 3. Let's say 3 3 3. Let's create 3 by 3 and full of threes. Yes, right now the size M3 is 3 by 3 and the size of M2 is 3 by 4. Their row counts are same, and that means we can combine them in a row. Let's say M4 equals to M2. We can use comma or space, doesn't matter, and M3. As you can see, the size of M4 is 3 by 7. The 7 is sum of 4 and 3. The 4 from M2 and 3 from M3. And let's define two row vectors. RV equals 1 1 1. And let's define another row vector is 2 2 and 2, and their sizes are, as you can see in here, 1 by 3 at the workspace. Size RV and size RV1. No, we don't have RV1, we have RV2. Yes, their sizes are totally same, so we can combine them in a row or in a column. Let's try RV and RV2. If you combine them in a row, we will get a 1 by 6 matrix, and if you combine them in a column, for example RV semicolon RV2, we will get 2 by 3 matrix. You can combine any kind of matrices into the one matrix. This is another way of defining matrices. And how can we access any element of a matrix? Let's clear the window. Let's define a matrix here. 1 2 3 4 5 6. And if you want to reach to 5 in here, you need to use its row index and column index. Its row index is 2 and column index is 2. If you write 2 and 2, it will return 5. And if you write 2 to 3, it will return 6. 2 to 3 means this is the row index, which is the second row. This is the column index, which is the third column, and this is second row, and this is the third column. Now it will return as 6. Let's clear the window and let's clear everything. We have colon operator. And what can we do with colon operators? we can define arrays, matrices, and vectors with a colon operator. What the colon operator does. For example, x equals 1 colon 1 colon 2 colon 7. Right now I have 1 3 5 7, but why? Because I used a colon operator. A colon operator creates an array with a start index, end index, and a step size. The first one in here is 1, is the starting point, and the second one is step size, and the third one is the end point. As you can see, it starts from 1 and it's adding 2, it's moving by adding 2 till to 7. And let's define another one. X equals, let's start from 2, and step size is 3, and let's go to 10. As you can see, it will create 3 numbers. It starts from 2 and it add 3 to 2, which is 5, and it's add another 3 to 5, it's 6. Why I don't have 10? Because when I add 3 to 6, the result will be 11, and 11 is greater than 10, so I don't have any element after 8. And we can use only starting point and end point. For example, x equals 5 colon 9. If we write this, we remove the step size, and the step size is 1 as default, and you can see that it starts from 5 and it's moving to 9 with 1 by 1. 5 6 7 8 9. Let's create something bigger. 1 to 100. As you can see, it's created an array starting from 1, ending with 100, and moving 1 by 1. And if you want to create an odd numbers, odds equals starting from 1 and ending at 100, and you need to add a step size here. Let's add a step size 2. Right now it will create all odd numbers between 1 and 100. And if you start from 0, right now it will give even numbers. Let me change the variable name. Now, as you can see, odd numbers start from 1 and increased by 2, and even numbers starts from 0 increased by 2. And we can also use a decreasing series. For example, we can start from 10. Our step size can be -3, and our endpoint can be 1. If you write this, your array will start with 10 and it will decrease by 3. in each step because our step size is -3. And let's look. If we start from 10 and our step size is 2, but our endpoint is 1, what will happen? It will create nothing. It will return a 1 by 0 empty double row vector, because if you start from 10, you cannot reach 1 by increasing 2. So it will create an empty vector. And let's clear the window again. Let's create a matrix. M equal 1, 2, 3, 4, 5, 6. And we don't forget the brackets. Yes, we have a matrix. If I want to reach the second row and third column of a matrix M, it will return me a scalar, which is 6. What about if I want to reach the whole row but the only first and third columns? Let's write. We need first row, then I write 1 for the row in this, comma, and I need to write the columns that I want. But this time I need to use brackets because I want to get multiple columns. For example, 1 and 3. Right now it will return me a matrix which is 1 by 2. It returned first row and the first and third column of the first row, which are 1 and 3. And let's create a bigger matrix. And we can extend our matrices. (9) equals 99. Oops, it's a little bit clear, and will clear only M. Let's create M equal 1, 2, 3, 4, 5, 6, and 7, 8, 9. We can use colon operator to access any part of a matrix, like we did with arrays. For example, I can get first and second column, second rows, and first and third columns. Now it will return to me 2 row and 2 columns of a matrix, 2 by 2 matrix. You can see that 1, 3 from first row and first and third columns, 4 and 6 from the second row and first and third columns. Instead of using matrices as an index, we can use colon operators. Let's see. From 1 to 2, comma, that means I want the rows starting from 1 ending from 2, and columns starting from 1 ending from 2. As you can see that it returned a matrix 2 by 2, which is first row, second row, first column and second column. And let's extend our matrix a little bit. 5.5 equal 99. Now we have bigger matrices, and right now I want to get the third row, and I can use M3, which is the row that I want, and column. The column here means that all columns. Right now it will return a row and all columns, which is 1 by 5, because I have 5 columns and it will return 5 columns for me. And at the same way I can get all rows and 1 column, let's say 5th column. When I try this, it will return a 5 by 1 matrix, which is the last element is 99, and this is a column vector, and this is the 5th column vector of that matrix. And if you use semicolon for row index and semicolon for the column index, it will return the whole matrix, because we want all rows and we want all columns together. And here, if you try to reach 6 to 6, it will throw an error. Why? Because M doesn't have 6th row and 6th column. But if you remember, if you write 6 to 6 equals 8, 88, it will extend the matrix. It doesn't throw an error. And at the same way, we can use multiple rows and multiple columns. For example, I can say that first row and from second column to fourth column. Right now, if I click enter, it will return me 1 by 3 matrix. And if I try to change these elements with 99, you will see that 2, 3 and 0 will change. As you can see, 3, 2, 3 and 0 are changed. At the same way, we can change here. For example, for the row index, we can start from 1, step size 2, and the ending point is 5. For the column, we can choose the third column equals 99. As you can see of third column here, the first row is 99 and step size was 2, and so 2 added to 1, the third row is 99 and fifth row is 99 too, for only third column. And if you don't know the ending point of your matrices, you can use a keyword which named end. For example, let's try to reach the first row and the last column, and you don't know the last column, and you can use end keyword. As you can see, it will return you the element at the first row and the last column. And at the same way, you can use and as a variable m1 comma and -2. Right now it will return 99. Why? Because here is the last column and last -1 and last minus second column. And also you can use like this 1 2 and no, not 1 3 to and it will return the rows starting from 3 to the end, and let's say second column. In here you can see that second column here, and we wanted the rows from 3 to the end, which are 8 0 0 0. And we can also change a part of a matrix with an array. How? Let's write. If we write 1 2 3 comma 1 not 1 2 2 4, now it will return 3 by 3 matrix. And let's remember what was our matrix. And right now I want to change the first and third row, first, second and third rows, and second, third and fourth columns with 55. And as you can see, I changed some elements in the matrix with 55, but if I want to change each element different, I can use another matrix too instead of a scalar. As you can see, it will return to me 3 by 3 matrix, so I can give a 3 by 3 matrix to change these parameters. For example, 1 2 3 4 5 6 and 7 8 and 9. And you can see that the first row and from the second column to third fourth column there is 1 2 3, and the second row 4 5 6, and the third row 7 8 9. But if you write here and 2 by 2 matrix, it will throw an error. Why? because the left side of the equation is 3 by 3 and the right side of the equation 2 by 2, and there is a difference. There is the reason of the error. You need to give the matrix with same sizes. And let's look at the transposing of a matrix. A transposing of a matrix, transposing a matrix is replacing a matrice's rows and columns. If you replace rows with columns of a matrix, you made transposing. As you can see here, A is a 2 by 3 matrix, but transpose of A is 3 by 2 matrix. And as you can see, the first row of A was ABC, and transpose of A, the first column of the transpose of A is ABC. Rows and columns are replaced, and this is the transpose of a matrix. In Matlab, it's so easy. Let's clear command window and let's try to create a matrix 1, 2, 3 and 4, 5, 6. This is our matrix, and let's say transpose matrix Tn equals m and transpose. In Matlab, you can use single quote to take a transpose of a matrix. As you can see, the size of n was 2 by 3 and size of Tn is 3 by 2 because it's transpose of m. And as you can see, the first row of m is a column in Tn, and the second row of m is the second column on Tn. And there is a 3-dimensional arrays in Matlab, and you can increase the dimensions 4, 5, 6, 7. It can go there. But for the simplicity, we can look to 3-dimensional arrays. The 2-dimensional arrays are matrices. And if you use multiple matrices in an array, if you put multiple matrices in an array, it will become a 3-dimensional array. As you can see in here, there is a 3 by 3 matrices and 3 times. We have 3 matrices, and each matrix has 3 rows and 3 columns. So right now we have rows, we have columns, and we have matrices. So we have 2 dimensions. In Matlab, let's clear the window. Let's remember what was M. As you can see, I have a matrix M, which is 2 by 3. But if I want to add, for example, first row, first column, but second matrix, you can see that 1, 2 and 3 dimension equals 0. Now it will create another matrix into the M. As you can see that this is the first matrix we created, and this is the second matrix right now we extended. And the Matlab filled the empty elements by 0. And we can change. For example, I want to change all rows, I want to change all columns, and I want to change only second matrix. So I need to give here 2 by 3 matrix equals, for example, let's say 6, 7, 8, 9, 10, 11. When you write M right now, you can see that this is the first matrix we have created, and this is the second matrix we have extended and we have changed. And if you add multiple matrices to an array, the array will become three-dimensional arrays. Will become a three-dimensional array. For example, let's get the first row, second column of second matrices, which is 7. Why? Because I want the second matrices, which is this one. I want this first row, which is this, and I wanted the second column, which is 7. And this is the end of our second lesson, and see you in the next lesson. Thank you.